So thank you very much. My name is Will from Akamai. It's very hard to follow Luke because he's been really passionate about media over quick for years now, and I want to give him credit for that. I've recently joined this movement, so I'm going to be talking on very much the same subject. We did not have a lot of time to collaborate on making sure we spoke about different aspects of it, so some part of my talk may trespass on his, but I'm looking at this movement over to pub/sub, which is another aspect of media over quick. The picture there is when I asked OpenAI to give me a sketch of a group of people around a table looking at complex machine parts and trying to put them together, that's what it came up with. But that's sort of where we are with Mock at the moment if you're involved in the meetings. So I wanted to just start with HTTP streaming. We take it for granted, but there's a rather curious loss of information that goes on with it. So I have an encoder. It goes to a packager. It makes me my CMAF segments. And what do? I stick them on an origin. I give them names, and I lose all notion of their temporal sequence. It's a flat file. I've stuck them on the CDN. So what I do then is I create a text file that recreates that temporal sequence, either through segment template or a list if it's HLS, and then I literally throw it over the wall to my player. And that's not a firewall, that's a knowledge gap. And the player reads the text file and it says, thank you very much. I now know what order to request segments in, and I can recreate that sequence that once used to exist. So this is useful for scale reasons, and it's useful for other reasons, but it sure would be nice if we could mutate something where we didn't have to break it up, right? We could simply take that stream that's nicely ordered in the region I want and move it right through to our decoder. Now, this is not a new concept. In fact, if your hair's gray like mine and you were doing media in the 1990s, this is what media looked like. But then it got replaced by adaptive streaming, right? And why? Because it wasn't originally designed for distribution via multi-party CDNs, third parties that weren't part of your distribution network. It's live edge only, as Luke just mentioned. You consume either live edge or you didn't consume it, much like WebRTC today. And it was focused either on contribution or distribution, but not trying to solve both. There were a lot of proprietary solutions around. They weren't open global standards, and there was a tight binding of codecs and media formats, so it's relatively inflexible. So if we want pub/sub, and media over quick is a pub/sub solution today, if we want it to succeed, it has to address all of these 5 issues here if it's going to succeed. Now you might just say, I've got quick, and we've got HLS and Dash. Let's just use HTTP3 with those, and we should get a performance uplift, shouldn't we? So I took some data from Akamai for one of our customers who has global distribution of content. I looked in Sweden, USA, and Brazil, and I broke out the traffic by whether it's H1, H2, or H3. And notice we're getting decent stats, like 55% of H3 traffic in Sweden for this customer. But let's start looking at some of the performance stats. Now, my perf group wanted me to put a big disclaimer that you must be very careful about any sort of perf. It varies with device, with geo, with the version of IETF Quick that we're running on the server, with the device, a lot of things. Anyway, for this customer, and I realize it's too small for many of you to see, for smoothed RTT, we're not seeing a large improvement with HTTP3. For throughput, certainly at the higher throughputs, we're seeing worse performance from H3. Now, that might not be causal. In fact, it's probably because most of the H3 devices are newer mobile phones, but the mobile networks don't have as much throughput as some of the fixed connections do, and therefore they can't have as much. So you don't know if it's H3's causing it or a symptom of it. And here in the United States, we see HTTP2 underperforming the other protocols for this client, for the slice that I took. So H3 is not jumping out. Where it does jump out slightly is in request time, my startup. And that's because of the 0 and 1 RTTs for starting up my session for my media. So we do see the green blocks there, H3 outperforming H2 and H1. But again, for server-side time to first byte, not seeing a major difference. And if I look at errors, you might get prematurely excited that there's 0 errors for, or at least 4XX, 5XX errors. But that's because H3 is, you have to step up to it. You don't make an H3 connection immediately. So your 4XX and your 5XX errors happen at your H2 or H1 connection, and you don't see them attributed to H3. Where I'm going with this is that there's not this dramatic uplift in performance by simply using HLS and Dash as they are today with HTTP3. They behave very similarly under good conditions. A lot of that is the reason Luke already mentioned. Quick is still head-of-line blocked if you're using a single stream. So if I have 3 streams multiplexed and A has loss, I still deliver B and C. But if it's all A's in a single stream, I'm still blocked on that content, just like using TCP. So if we want to get better performance out of Quick, I've got to look for conditions where there's loss, and I have to be using multiple streams in parallel to take advantage of Quick's transmission. The other area, and again, Luke showed this, I'm going to show it slightly differently, is in flexible loss recovery, right? So here, imagine I'm a server and I'm sending an iframe, BP. I have some loss in my B, and now, on top of that, my encoder's got new data that it wants me to send, the blue blocks. So as the sender, what should I do? I've got some choices, right? Number one, I can just retransmit the B and then go back and retransmit the blue, right? Or I could send the blue frames first because they're more urgent and then go back and fill in the B. Or I can ignore the B entirely because it's in the past and I know my player isn't going to even use the data if I send it, and just send the. Now, option one is what TCP does, and it's all that TCP does. But with Quick, we have the option to do all 3. Now, it's only an option because where's the information to tell us what to do, right? CDNs don't know exactly what we should do because they're just binary pieces of data. We don't know how they interact. We need explicit signals for these, and basically, we need a new protocol that enables this refined response to congestion to happen at scale and across CDNs. So hence IETF, media over Quick. This is a lot of text on this slide, but basically charted in September 2022, looking to build a simple, it's described as a low latency media delivery solution. It's really a tunable latency media delivery solution that's covering the live streaming, the gaming, and the media conferencing worlds, which today exist in quite separate solutions and certainly don't all leverage CDNs or the same CDN. It works on browsers and non-browsers, and it's a common protocol both for ingest and distribution, one that's cache-friendly, one that can handle rate adaptation. And it can be used with raw quick or web transport. These are clearly aspirational items, right? We're working towards this. So today, if we want a little snapshot, we have raw quick, we have web transport on top of that. We have a notion of something called mock transport, which is a pub-sub protocol for moving binary messages, sitting on top of either web transport or quick, your choice. And on top of that, we're then going to layer a selection of what are called media formats now. The name might change. But the idea is mock transport's a lot like HTTP, and the media formats are HLS or Dash or Smooth. You can innovate on the media side and decouple it from the binary message side on the base layer. And if you're building a CDN, you only build the red block, right? You don't worry about all the other blocks because you'll automatically be compliant with them. If you want a real snapshot, what do these messages look like? They're broken up into control messages, object messages. Here are some of the control runs as of this week. They might be different next week. I put a little star. All of these are subject to change, and then I just didn't star everything. So assume they're all subject to change. Some ideas, if you care for it, there's varents to describe the type and the message length. That's the common message. And then in an object message, which is the one that carries media, I've got track IDs, I've got group sequence numbers, object numbers, a send order, and then my encrypted payload, which is where my media goes. A relay can read the green stuff and the blue stuff, but it can't read the purple stuff, and it doesn't need to. It's important that these objects are organized into tracks. A track is a temporal sequence of objects, like your 1080p video stream, that would be a track. And the tracks themselves are organized into groups and objects. So here's a group comprised of several objects, and it's followed by another group comprised of more objects. The group represents a join point to the stream. So if I was going to map this to AVC content, I could put an iframe at the start of every group, and my group would be a GOP. It's a pretty simple mapping. It's not the only mapping we might envisage. If you go to SVC or you go to VR solutions, it's not going to look like this at all. We're also introducing the notion of a catalog. So catalog's a new word for you, and it'll probably appear more in these conferences in the future. It's a special track. It's a reserved name. And its purpose is to list all the other tracks that carry the media, metadata about them, initialization data for them, and also updates about their availability. Are there more of them? Are there less of them? Are they still available, or are they gone? And catalogs can be monolithic, just here's everything that's available, or they can be delta updates. They can describe just a small change in the track. Key issues being debated right now, there are many of them. How publishing should work. Do we need to announce tracks? What's the naming scheme for these tracks? Do we need global GUIDs everywhere? We don't want to carry that much overhead in our protocol. What are the priority streams? How do we inform servers to do that selective dropping that we mentioned earlier? How do relays interact? How do we do variable quality? And a lot more discussions. It's all very public. You're welcome to go on the IETF website, read the mailing lists, and look at the meeting minutes. There's a virtual coming up on June the 5th, and then in San Francisco on IETF 17th will be the next face-to-face. You can absolutely get involved, and if you find Luke, myself, or Alan, who's co-chair of the group right here, he's got his hand up. We'd love to get more people interested. I wanted to end, I have a few minutes, just with some demos, screen recordings of them, to show you that even this early on, with as much stuff up in the air and people juggling things, that there's workable solutions already coming out, and I find them quite fascinating. So this is a demo of Luke's Twitch, but I think built by guys in Turkey, and they may even be in the room here, they just mounted it. I captured this demo right after Firefox released support for web transport. So I have Chrome on the left, and Firefox on the right. And Firefox and Chrome are competing for resources right now, so it's pretty interesting to see which one's winning. Firefox is winning, is the detail, and it's hard to see on the screen, but the latency on the Firefox side is about 250 milliseconds. So again, this is real time coming out of an encoder. So that's a derivative of Warp. This is a demo built, this is Chrome browser, I'm filming a screenshot built by Bernardo Boba at Microsoft, and it's showing the interplay between web codecs and web transport and mock. Because with web codecs, I now have full control over my encoding layer using JavaScript. And what I'm doing here is encoding with web codec, sending it via web transport to a server, sending it back, and looking at the time delta between the two. I'll probably hold up my phone. In this case, it was probably about 500 milliseconds or so. This is not WebRTC we're looking at, right? This is an early version of Media over Quick, if you will. Here's another one. This is QuickR demo in a collaboration with Cisco. I'm in San Francisco. I mounted a relay server on our Linode instance in Atlanta, and I'm playing it back. It's not a web-based demo. Again, latency about 400 to 600 milliseconds with this very early prototype. This is one from Jordi Cenzano at Meta. It's a new one, and it's again using web codecs. It's similar to Bernard's, but Jordi introduced a very interesting capability that you can choose your latency. You don't have to be bleeding edge live. You can step back 5 seconds or 10 seconds if you want and play that. In fact, you can even play a VOD file from what was recorded. As long as the relay server caches it for long enough, you can watch the content. And that, I think, shows some of the real promise behind mock, that we can do VOD with it, we can do selective latency, and we can do real-time communication. So this is all done in the web browser with a couple of hundred lines of code. It's quite impressive. And with that, I'll say thank you very much, and happy to answer any questions. Cheers.
Questions? So thank you, Will. Very interesting. So as an end-to-end, you know, from encoder to packager, CDN, what bottlenecks do you see, like moving to Quick or HTTP3? Like, where do you see, like, are encoders maybe not supporting it, or origins? What's your feeling about that?
Yeah, it's been how many years since the spec was released, and we're still, Akamai is rolling out global support for H3 last month, so we may not be the fastest, but we're one of the biggest, and it's taken a while to get it out there. So you've got to move very carefully with H3. I expect bottlenecks at all the layers you mentioned. Encoder, certainly for mock, The biggest thing I'm concerned about is the scale of a pub-sub network. Pub-sub have been small, right? They haven't been global. A lot of them rely upon real-time updates of dynamic tables to route information. That's very difficult to get to work at scale. I can't have a global database that I update instantly if I need that to route information. So we have to be very careful how we break it up. It's a lot like DNS and similar systems. We have to recreate something. So I see bottlenecks inside players, handling it correctly. I think all of the complexity about the prioritization, that's going to be a minefield of places to shoot yourself in the foot. And we're going to have to resolve those. So it's going to be many years till we have production systems that we can run businesses on, but there's going to be an awful lot of experimentation between now and then.
Hey, Will,
Hey.
What about devices? What challenges or constraints do you see on devices?
Very similar ones. There's unknown player types. I hope early on that we release like reference players that people can innovate on, that there isn't proprietary direction. The client stack, okay, QUIC is a bidirectional communication, right? It's always a cooperation between a server and a client. And at W3C, I chair the Web Transport Working Group, if other people want to get involved in that, trying to figure out what's the API we need on the browser, and what level of control should be given to JavaScript, to the application layer, how much should be within the browser stack, and how do the two cooperate so that we can scalably deliver media. So yeah, it's fraught with danger, but also exciting opportunities.
So one question. Are there any thoughts about adding FEC to the protocol using unreliable datagram mode and forward error correction?
Adding what to the protocol? Sorry, I couldn't hear you, Alex.
Forward error correction.
Sorry? FEC. Oh, absolutely. So FEC, if you're sending datagrams, which is one of the addressable units, right, then you can roll your own FEC. And you would need to, because otherwise you're going to accept the loss. But the attraction, the excitement is with JavaScript now, or an enhanced version of that, I would be able to implement my own FEC protocol. So I know QuickR, the demo that I showed, that uses datagrams for transmission. It doesn't use frame per stream or GOP per stream that the other solutions did. I'm a little scared of the write rate that we need to handle at a CDN for that. That's to be looked at, and even if we need to go to datagrams, because there'll be thousands of them per second for higher bitrate content. But it's a long answer to your question of, is there an opportunity for custom FEC? Yes. Application level FEC.
Good. So, thank you, Will.